You click a download link on a site like preventionweb.net, expecting to get your file immediately. Instead, your progress stops at a stark white loading screen that politely informs you it is checking your browser. Originally, the internet was designed as an open public square. A user's click instantly connected to a host server, and that server provided the data without friction or inquiry. This chart shows how much that environment has changed. It tracks total internet traffic volume, and as you can see, over 40% of all current traffic is entirely non-human. This volume consists of automated scrapers, DDoS bots, and malicious scripts constantly probing every reachable server for unpatched vulnerabilities. This creates a significant architectural problem. From the perspective of a server, a legitimate human click and a coordinated botnet request look nearly identical in the first few milliseconds of contact. Direct, that 5-second delay represents a high-stakes frontline defense mechanism. It acts as a gatekeeper, interrogating the connection before it ever reaches the core server infrastructure. The interrogation follows a strict micro-timeline, beginning the moment the screen claims to be running a routine check. First, the system logs your origin details. It notes your IP address, in this case 74.125.209.137, and your precise geographic location. This animation represents the screening process. The system instantly cross-references your IP address against a global database of known threat actors to establish your historical reputation. Once the IP passes that initial check, the system assigns a unique Ray ID, like 9FE8D13569D4B9C7. Think of the Ray ID as a unique tracking fingerprint. It is assigned exclusively to this interaction, allowing the security layer to trace your specific behavior across the entire network. This filtering step ensures that the system is not just looking at a single request, but comparing it against the entire history of internet security threats. If the origin looks clean, the system moves to a secondary set of commands: enable JavaScript and cookies to continue. The cookie acts as a digital memory token. It proves the browser is maintaining a continuous, valid session, rather than making an isolated, stateless request. Basic bots often fail here. They are usually designed for high-speed, single-stride operations and lack the internal logic to store and return tokens. Next, the server utilizes JavaScript to force the browser to execute hidden code in the background. This shows the computational challenge. The server requires the browser to complete a specific set of resource-intensive calculations. Completing this proof requires actual processing power and a functioning browser engine. A standard web browser processes these calculations effortlessly. However, a lightweight, malicious bot script typically lacks the full rendering capabilities required to provide the correct answer. Only after the browser returns the correct proof and the valid cookie does the system trigger the verification successful message. In those few seconds, the browser passed a silent Turing test. It provided mathematical proof of its true identity without ever requiring the user to solve a manual puzzle. Once the verification is complete, the invisible gates open and the destination URL finally delivers the requested file. While this happens millions of times a day, the broader implications define the architecture of the modern web. The internet no longer functions as a wide-open highway where every request is accepted at face value. Instead, the web has become a series of gated communities. Every incoming connection is treated as a potential threat until it can provide the necessary computational proof of innocence. This loading screen represents a sophisticated layer of engineering that processes billions of interactions daily to filter out automated traffic. This 5-second window is a massive, invisible interrogation. It is a continuous effort to separate human users from a constant barrage of machine-driven requests. This automated screening process allows the modern web to remain functional, preventing the flood of automated traffic from overwhelming the servers we rely on every day.